Hi all, today we are solving LeetCode problem number 1390 for divisors. Given an array which is an integer array of nums, return the sum of divisors of the integer in that array that have exactly 4 divisors. If there is no such integer in that array, return 0. So what exactly it means? So you have to iterate through the array. So for a particular number at any index, example nums of I, you have to find the divisors, and if the number of divisors for nums of I is exactly equal to 4, then sum it up and add it to the result. And if there is not exactly 4 divisors, return 0. So let us understand this sum with the first example. So we have nums 21, 7, 21, 4 and 7. So take the first number. 21 has 1 and 21. Then we do have 3 and 7. So totally it is 4, and 4 has 1, 4 and 2, which is 3. The count is 3, and 7 has 1 and 7, so the count is 2. So since the length of devices available, the number of devices available for 21 is 4, you have to sum these all, which will result in 32. So return 32 as the answer. So let us understand this with one more example. Let me name it as 2, and we have example 2, nums as 21 and 21. So nums 21, 21. So here for 21 we have 1, 21, 3 and 7, so which is 4. Sum this up, which is 32, and similarly in the next iteration you will land up on this particular index, which is 21, and the same step you will get 32. So you have to sum this up with the result. So already in the first iteration the result will be 32, and in the second iteration the result will be updated to 64. So you have to return 64 as the answer. So if you see the third example, here we have 1, 2, 3, 4, 5, and none of this number has 4 devices or more than 4 devices available. So because of that we are returning 0. So how can we solve this problem? So what is an approach? So we can do one thing. We can iterate. For example, if we have 21, we can iterate from 1 till 21, 1 to 21, and divide 21, and if dividing that or by performing a modulo operation, if it gives 0, then that particular number we can add to the set, and we can do that. But this is the brute force solution, and if you go to the problem constraint, let me open the problem. And if you go and check in this constraint, you have the length of the array at the maximum 10 power 4, and the maximum the limit of nums of I, the nums of I range between 1 and 10 power 5. So if you if then the highest number is 10 power 5, and we are calculating the sum for the divisors, so this will be the total calculation would take somewhere around 10 power 9. So for 10 power 9, by calculating by this regular brute force will not be efficient, and this will result in time limit exceeded issue, and the problem won't be efficient, the solution won't be efficient. So what is the alternative approach? We can iterate from 1 to square root of uh, that particular number, nums of I. So in this case, the square root of 21 will be somewhere around 4 point something. So you have to round that, and you have to take the value. So with that, we have to check in between 1 to 4. So, and here we have to we have to observe one more thing. So we can do this now. So we will take 1 in the first iteration, and we will divide 20. We will check with the modulo. So 21 modulo 1 is 0, and with this we can say that since 21 modulo 1 results in 0, then 21 divided by 1, the quotient will be quotient, and the the quotient and the divisor will be a symmetric pair always. So we can add this pair to the set. So in this case, if it is 0, then definitely 21 will be divided by 1, right? So in this case, this 21 this 21 is the quotient. So I'm sorry, I'm confusing. So if we divide this by 1, you will get the quotient as 21, and in here 21 modulo 1 we are getting 0. So this will be a pair, and this will be a pair, forms a symmetric pair. So if you check for 21 modulo 2, you are not getting 0. So we can skip this, and 21 modulo 3 will give 0. So this will be one pair, and 21 divided by 3 will be 7, and 7 will be the other pair. So if we see, we get 4 pairs in total, which is 1, 21, and 3, and 7. So these are all the pairs, and we sum this pair and we return it. So with all this observation, we can jump into the coding part. So here we have to return the result, and and we could see we have the default value of the result as 0, because if there is no divisor, which is the number of divisor for a number is not exactly 4, you have to return 0. So because of that, res is 0, and you have to check for every number. So you have to iterate through the nums. So for x in nums, and you have to, we are using a set to track the available divisors. So and as I said, we are iterating from 1 till the square root of the number. So and we have to floor that up, and we are processing it from 1 to the square root of number, and we are checking with the condition. So with that, 1 2, we have to floor it up because we have to round the value. So and since this is non-exclusive, we have to add 1 so that the last uh, rounded value will be included for checking. So modulo check. If this is possible, then we will be able to form the symmetrical pair. So we have to add the each pair to the set. So div dot add, we're adding d, and we have to divide it by x, and we have to add it. And at the end of iteration, we have to check if the length of set equals 4. If yes, you have to sum the complete set, sum the numbers available in the set and add it to the result. So and there you go, you already returned result. So yeah, talking about the time complexity, so we are using a linear loop to iterate through the nums, right? So because of that, we are having big O of n for processing this linear, and we also have a nested loop where we are processing till square root of the value. And if you carefully observe this, you will check that the maximum square root value is possible if you consider this 21. So the square root value of 21 is 4, and the square root value of 7 or 4, if you consider, that is very less than the square root value of 21. So this will be square root of max number of nums. So the maximum number available in the nums array, its square root multiplied by the n. So this will be the time complexity. And yeah, let's go ahead and submit this. I'm sorry, there is a typo. And this is an efficient solution. Thank you.